Okay, continuing on. And by the way, if you're expecting this to be perfect, really? All right. So what we're saying is that we want to turn our slope, which is 0.0039, into a fraction. Talk about change in y over change in x. And the way you can take any value and turn it into a fraction is to put it over 1. Okay, that's really simple. Now, let's talk about what's happening here. If you have a positive correlation, and a positive correlation means that you're moving up and to the right. As we talk about it, when we talk about direction, we say as x increases, y increases. So as x increases, y is going to increase. But if we have a negative correlation and we're going down and to the right, what we're saying is this, is as x increases, y decreases. Now this is really helpful because no matter what, as we're talking about this, x is going to increase. And since we have a 1 here in the denominator, what we're going to say every single time is as x increases by 1 unit, whatever the unit is. In our situation right now, our unit is SAT point. Yes, it is. SAT point. So as x increases by 1 unit in SAT point, what's going to happen in y? Y is going to increase or decrease whatever the slope is, and it's going to be unit of y. So what we're saying here in our very specific situation is as x increases by 1, our unit happens to be SAT. As x increases by 1 SAT point, then what's going to happen is because because our slope is positive, freshman year GPA is going to increase by 0.0039 freshman year GPA points. So when you are talking about slope, it will always be whatever the value for slope is over 1, and the change in y will be the change in whatever the slope value is, whatever units that are on the y-axis versus 1 unit along the x-axis. I hope that makes sense. Okay. So here we are, and here's our graph, and here's our graph. So, next thing we're going to talk about is the equation, what the actual equation for line of best fit looks like. And granted, when we look at y equals, we see, here's the equation, negative 1.46 and some stuff, plus 0.0039 times x. In statistics, we very specifically write the equation for the line of best fit as this. This has a very, very specific name. This is not y, this is y hat. And y hat means predicted value of y, because that's what the line of best fit is. It is a prediction. It is a model that we're using to represent the entire data set. And it's the best model that we can come up with. So y hat is equal to b0, that's b0, plus b1, even it's sub-zero, b0 plus b1 times x, whatever your x unit is that you want to use as your explanatory variable. Keeping in mind that this is written in the form a plus bx, which was linear regression choice 8 when we were doing the regression, where b0 is the, like you can see what that is, it's the y-intercept, and b1, I'll put up here, b1 is the slope. If you look at the formula sheet, let's run it over here and find one. There it is. Here's the formula sheet that comes with the AP test. As we're looking at the formula sheet, the fourth formula down, and you can't see it from here, but you've seen it in class. The fourth formula down is y hat is equal to b0 plus b1 times x. Underneath that is a lovely formula that tells you how to find slope that you'll never, ever, ever have to use by yourself, but it's one of those things that if you can apply it, you can. It has to deal with each value of x minus the mean, each value of y minus the mean, multiply them together, sum them, divide by each value of x minus the mean, squared, summed, huge, huge deal there. That would be the slope. Of course, we would use our calculator. Okay, so there is our equation, the y hat is equal to. All right, so what we're going to do is I'm going to bring up the Fathom program again here. And we're going to bring up the graph, or we're going to bring up the graph of SAT predicting freshman year GPA. And we're going to make it bigger. And we'll put in the line of best fit. Here we are with the line of best fit, otherwise known as the least squares line or the regression line. And what we're going to do is I'm going to kind of cheat down here. Let's see if I can grab this down here a little bit. I'm going to write on this. Do I have old information here? I don't. That's convenient. Okay. So y hat, here's our equation for our line of best fit. Y hat is equal to B0, which was our y-intercept, which is negative 1.466. I'll call it negative 1.47. Plus the slope 0.0039 times x, and x here happens to be SAT points. So what we're saying here is our predicted freshman year GPA is equal to negative 1.47 plus 0.0039 times whatever SAT score we want to go with. All right. So we're going to start off with a value of 1200. And what we're going to do is we're going to put 1200 in for this value. Grabbing a calculator. Hang on. Wait, I have a calculator. Grabbing a calculator, and we will clear this because I'm going to do this in, oh, that's a bummer. Oh well, I don't need that right now. There again, no, quit. I'm good at this. All right, so what I'm going to do is negative 1.47 plus 0.0039 times 1200 equals 3.21. So, coming back to this graph right here, and we'll go back to drawing on here. So if the SAT is 1200, the predicted freshman GPA is 3.21, which means that would be the point 1200 comma 3.21. That's right here. That happens to be right there on the line. What a surprise, because everything I put in here is going to be on the line. That's the equation for the line. So there's 1200, 3.21. The problem is, it's not right. I know it's not right because there's the actual point. If I look right here, here's an SAT score of 1200. This person got 3.92, not 3.21. They're actually right there. So what I have here is I actually have, right there, I have where I'm wrong, and that's how far I'm wrong. That's the vertical distance from the observed value down to the predicted value. So I'm going to get off of this for a second, and we'll come back to here. And what we have is we have the observed value minus the expected value. And if we think about the variables, the observed value is actually the y coordinate. And we're running out of time here, so we'll be back in a second.